Hello everyone, my name is Gustavo. I work in the Developer Relations team of Amadeus for Developers, which is the Open API program of Amadeus. Our goal is to provide travel data and services to developers across the world. And today I'm going to show you how to create an automatic CI/CD pipeline using GitHub and Amazon AWS. Before getting started, let's review what is a CI/CD pipeline. CI/CD stands for Continuous Integration and Continuous Deployment. The continuous integration part is to automatically build, test, and merge new version of software to a code repository. The continuous deployment is to deploy this new version to a production environment. So, with an automatic CI/CD pipeline, developers can have their code in production within minutes of the code writing, which is extremely important for releasing new versions of software and minor fixes. Now let's review the AWS services we are going to use for this project. First, we have EC2, which is used to create server instances. These instances can be seen as virtual machines hosted in the cloud. We are going to create a Linux one to run our application. Next, we have code deploy. This service is responsible for injecting the files from our GitHub repository into our EC2 instance, and also to trigger the building steps of the app to prepare it for running. Then we have Secrets Manager, which is used to securely store secret credentials that can be later accessed throughout AWS services. And finally, we have CloudWatch, which is used to monitor and observe our application logs. You can also create custom metrics, alarms, and rules with automatic actions. Now let's take a quick look at the application we used as an example for this tutorial. The front end was built using the Svelte JavaScript framework, which is growing really fast lately and often pointed as one of the most loved by developers. The backend was built using Node.js and the Amadeus Node SDK. Also, the front-end was compiled to static HTML and served by the backend. So the only service that's going to be running is the backend. Also, the whole application is Dockerized. So in the EC2 instance, we are going to run Docker. Now let's jump right into the prerequisites. First, you need an AWS account. And although all features used in this tutorial are eligible in the free tier, you should pay attention because when you reach certain limits, AWS starts charging for their services. So it's highly recommended to check the AWS pricings before starting. And then you just need a GitHub account and a repository containing the application you want to deploy. You can use ours, just forking the repository we use it. The link will be in the description. Let's get started by configuring our AWS environment. First thing we have to do is to create IAM roles. In AWS, roles is what allows AWS services to call other services on your behalf. So for example, to push the application logs to CloudWatch, we need a role that allows us to do it. So let's start by searching for IAM here in the search bar and clicking on the IAM service. Now here in the IAM dashboard, under Access Management, we can go to Roles and create role here on the right. First, we're going to create the role for our EC2 instance. So trusted entity type, you can leave AWS service, and common use cases, you can select EC2. Click on Next. In this screen, we're going to add the permission policies. So first permission we need is for code deploy service. Search for EC2 role for, EC2 role for, and select Amazon EC2 role for AWS code deploy. And okay, this is added. You can delete the filter. Next one is the role for Secrets Manager. So search for Secrets Manager and add this policy, Secrets Manager read write. And finally, the last one, delete this filter, is CloudWatch Agent Server Policy for the CloudWatch service. So CloudWatch Agent and server policy. Okay, now we just added the 3 permissions we need. We can click on Next. Here you can give your role a name. I will give it EC2 row. Oh, sorry. So we don't get confused. And okay, it's all good for me. The policies we added, you can leave as it is. Create row. Perfect. Now let's do the same thing, but this time we're going to create a row for the code deploy service. So click on create row, choose AWS service. This time we're going to select code deploy under here and select code deploy. Next, we're going to add this policy, the only one we have, and click next. Let's give it a name, code deploy row. Everything is good now. Let's click on create row. The last thing we need to do here in the IAM dashboard is to create a user for GitHub. An user works more or less like roles, but for external services. So we are going to create a user that allows GitHub to access the code deploy service. Go to the users here under access management and add user. Give your user a name. I will give it GitHub user. And for the select AWS credential type, select programmatic access. Next to permissions, select attach existing policies directly. This will work similarly to the roles section, and we're gonna search for code deploy full access. Enter, and we will add this policy. Next to text, this is optional. We won't add anything here. Next to review, it's all good. You can create your user. Now, what's important is this. You can access this later, but when you are creating your GitHub deployment, you will need these credentials. So you can note it now, the access key ID and the secret access key, or you can just come to the IAM dashboard later and have it. Now that all our IAM roles and users are set, let's configure our CloudWatch service. So search for CloudWatch. Let's go to its dashboard and let's wait for it to load. Here on the left you have logs and logs group. Click on log groups. We need to create a log group and a log string. Here you can click on create log group, and for the name, as our application is called, I don't know, flight search, let's name it flight search log group. For the retention settings, you can choose like for how many days or months or years your logs are going to be stored. I'm going to put 3 days because I don't need more than this, but you can choose whatever you want. You can leave everything else as it is, and let's click on create. Great, our log group's created. Let's click on it, and now we need to create a log string. So here on the bottom, you can click on create log string, and let's name it flight search log string. Okay, good. Click on create, and everything's done. Now it's time to configure our secrets manager. So as usual, let's search for our secrets manager, go to its dashboard, and here on the right we can click on store a new secret. So as I told you, we are going to store our Amadeus API credentials. So for us it's other type of secret. We're gonna choose a key value, and we're gonna add our credentials. So Amadeus client ID, and you can put your client ID, put your actual client ID here, and then Amadeus client secret. You can do the same thing and click on next. Here is the secret name. I'm gonna name it flight search slash Amadeus credentials. And for the description, you can put something if you want, and everything is good now. You can click on next. You can also configure an automatic rotation of the secret, but we don't need this. We are not gonna use rotation, so just click next. And everything is good. This is some scripts, some sample codes that they provide to you, so you can retrieve your secrets in different SDKs, but we're not gonna use it, so let's just click on store. Good. Now it's finally time to create our EC2 instance. So search for EC2 and let's go to its dashboard. Here in the EC2 dashboard, you can click on Launch Instance here in orange and Launch Instance. Okay, in this screen you can give your instance a name. I will name it Flight Search Instance. Then for the application OS image, select Amazon Linux and this Amazon machine image, Amazon Linux 2 AMI, 64 bits x86 because this is eligible for the free tier. Same thing with instance type, leave T2 micro, which is also eligible for the free tier. And here for the key pair login, select proceed without a key pair. Of course, you can set this if you want, but it's not mandatory. Here on the network settings, let's create a security group, and for the traffic, for the network traffic, let's allow SSH, HTTPS, and HTTP from anywhere. You can customize these after, if you like later, if you want to add more incoming or outgoing traffic on other ports. You can configure all these later. Configure storage, leave as it is, and in advanced details, let's select the IAM role we created for our instance. It's the EC2 role here. Now everything is good. You can click on Launch Instance here. It's gonna create it. It can take a while, and after it, you're gonna see your instance here. You see in instance state it's pending because it takes a while to initialize. Now that our instance is running, I'm gonna really quickly show you how to add more inbound and outbound rules to the network traffic, because even though we're not gonna use it for our application, it's really important for other applications. So click on your instance ID. You're gonna be taken to this screen, and here on the bottom, select security, and under security group, select your security group. You're gonna be taken to this screen where you can personalize your inbound and outbound rules. Just click on edit inbound rules, and you can add a rule if you want, and that's how you do it. Now that our instance is up and running, let's connect to it. Click on your instance ID here. Just before connecting, check the region where it is, so you can go up here. I am in North Virginia, and the code of the region is US East 1. We're gonna need this later, so keep it in mind. Here in the instance dashboard, we can click on connect, and then connect again. This is going to open a terminal in our instance, so we can execute some commands there. First thing we're gonna do is to update our software. So let's run sudo yum update. Okay, let's say yes. We're going to update all of them. Okay, cool, it's completed successfully. Now let's install first. We're going to install Ruby with sudo yum install -y Ruby. Good, it's installed. So now we're going to try to install wget. Probably it is already installed, but we're going to check sudo yum install wget. It was already installed, no problem. And now we're going to download our Amazon code deploy agent. For this, there's a little trick. The URL is this one. I'm gonna paste it here to you. Paste. But we need to replace the bucket name and region identifier with our own. So to do this, go to this website. I'm gonna leave the link in the description and search for a region. For me, it was US East North Virginia. So my bucket name is this. Let's copy it and replace here in our URL. Paste. And the region identifier, we do the same thing. It's the last part of the bucket name, so US East-1. Now, this is the URL to download your code deploy agent. Just let's sudo wget, and it should be good. It's downloaded. Now we're gonna make it executable with sudo chmod +x to /install. Good. And now let's execute it. Sudo /install with auto. It's going to install our code deploy agent. Good, it's completed. Now let's start the service. Sudo service code deploy -agent start. It started. Perfect. Let's just delete the installer so it doesn't take place in our instance. Yes, I want to delete it. Good. Next step is to install Docker. So to do so, let's do sudo yum install -y docker. Our application is Dockerized, that's why I'm installing Docker, but it depends on your application. You can run it directly if you want. Good, it's completed. Now let's create a group for Docker, sudo group add Docker. It already exists, good. So sudo user mode -ag Docker, and we're gonna take the current user with this environment variable. Perfect. Next, we're gonna add Docker to start on system startup with sudo systemctl enable docker.service. Perfect. And now, same thing with sudo systemctl enable containerd.service. Perfect. Now let's start Docker. Sudo service start. Sudo service Docker start. Perfect, it's running. Finally, let's install our CloudWatch agent. So to do so, sudo yum install Amazon CloudWatch agent. Yes. Good, it's installed. Now we need to configure Docker to push the logs to the CloudWatch agent. To do so, let's go to the folder /etc/docker. And here we need to create a file called daemon.json. So let's do it with vim. So sudo vim daemon.json. In this file, you have to paste this configuration, and what you have to do is replace the information here with your own. So for me, the region was US East 1. Our CloudWatch logs group was flights search log group, and our stream was flight search log stream. Perfect. You can save it, and it's all good. We need just to restart Docker for this to take effect. So sudo service docker restart. We are all good now. Actually, there is one more software that we need to install, which is JQ. It's a Json Parser. We are going to use it to parse our secrets when we retrieve it later. So this is simple. Just type sudo yum install jq. Okay, good. Let's put yes, and it's installed. Now that our EC2 instance is configured and all the needed software installed, let's configure the code deploy service. So let's search for code deploy. Let's go to the service. And here on the left, under deploy, click on applications and then on create application. Let's give it a name, flight search deploy. And under computer platform, choose EC2/on-premises and click on create application. See, the application is created. Now go to deployment groups and then create deployment group. We are going to name it flight search deploy group. And here under service role, you have to choose the service role we created before, this one. Under deployment type, choose in place. Environment configurations, it's Amazon EC2 instances. And now we have to search for our EC2 instance. So in the key field, choose name, and the name of our instance is flight search instance. So let's put it, and you can see here we have one unique matched instance. That is what you should see if everything goes right. Next, this you can leave as it is, and under deployment settings, choose one code deploy default one at a time, and disable the load balancing. Now you can click on create deployment group. Perfect. At this point, all the configuration on the AWS side should be completed. Now the last step would be to create an appspec.yml file in the root of your project folder. So let's take a look to this file. Here we have version, which is usually 0.0, OS in which all of the scripts are going to be run. We are using Linux. Then files, you tell to code deploy which files you're going to install in your instance. So we're going to copy all the files in the root of our project to this folder flight search app in the EC2 instance. And we are going to overwrite if there is old versions there. Permissions, you are giving permissions on this file to the EC2 user as owner and group. EC2 user is the standard user for EC2 instances. And now the most important section is hooks. Hooks are what we have to know is each code deployment has several steps. So before each step, a hook is executed. So let's say before install, it's before downloading the new code. So what we have to do, we are going to execute the stop script as the EC2 user. So let's take a look at this stop script. What we do here, we stop the current container if it exists. That's why we add this or true here, because otherwise the script would fail if the container doesn't exist. Then we delete this container and we delete the image we are using. So we can prepare the instance for the new version of the application. Back here we have the next hook, which is after install. This is after the source code is copied to the instance. So we see here that we execute the build script, and let's see what it does. It tells Docker to build the image, which will be called flight search app with these build args. This is important because your frontend has to know the public IP of your backend. So here you have to put your instance public IP. You can get this in the Amazon EC2 dashboard, and clicking on your instance, you get all the information there. And here is where the files are located, where the Docker file is located actually. Okay, back to the appspec.yml, we have finally application start. So after the code is copied, the Docker image is built, we have to run it. So let's take a look at the start script. Here we do some important things. The first two lines is to retrieve our Amadeus credentials from our secret manager service. So what you're going to do here, we're going to call the AWS Secrets Manager get secret value function. Here you have to put some parameters, which is your region, ours is US East 1, and the secret ID. So we named our secret flight search / Amadeus Credentials. We added this query option here only to retrieve the secret string, because this function returns a lot of information about your secret, but we just want the secret string and the output to be text. Now what we have to do is to use JQ to retrieve only the desired information on the JSON that's returned. So for the client ID we have to put this, and for the client secret we put this. JQ is just a Json parser for the command line. Finally, we can run the docker command with -d to detached mode, which is it's gonna run on the background. Then we're gonna pass the environment variables we just retrieved for Amadeus client ID and Amadeus client secret. This environment variable is also important because you have to tell your application if the Amadeus environment is production or test. In our case, it will be test. The -p parameter is to tell Docker how to map the local ports to the container ports. So we know our application listings on port 3000 inside the container, and we want to map it to the port 80, which is the standard HTTP port for the local host, which is our EC2 instance. Finally, we name our container Flight Search App, and we specify the name of the image, which is also Flight Search App. Now let's configure our GitHub repository to automatically deploy to AWS. First, we're going to need the GitHub user we created before in AWS to allow GitHub to access these services. So, you know it's not safe to hard code credentials, so let's use GitHub's secrets feature to store them securely. Go to Settings, here, choose Secrets and Actions. Here you see I already have my secrets added, but you can just click on New Repository Secret and add yours. We just need these three secrets. AWS ID, it's the ID of your GitHub user. AWS secret is the secret. And AWS region, it's your region, just to be easy, so you can just put it there. The final step is to create a .github folder and a workflows folder inside that folder containing a .yml file, which is going to describe the GitHub action that's going to be triggered. So let's take a look to this file. First we have the on, it's the action that triggers all these jobs. We have the push action to the branch AWS. Good, so each time I push code to this branch, these jobs are going to be triggered. Next we have the jobs. Here we see we only have one job, the deploy one. It's good to, if you have some tests to your application, it's good to execute these tests before the deployment, so if the test fails, you don't deploy it to AWS. But here, to make it simple, we're just going to directly deploy it. So in the deploy job, we have the name of our job. It runs on Linux. The steps. We have two steps. First, to configure AWS credentials. So we're just going to retrieve it using the GitHub Secrets API. It's really simple. You just put dollar brackets and secrets dot the name of your secret. Okay. Next, we have the create code deployment. Then we're gonna to do this, we are going to execute this command here. And then we're going to specify the parameters application name. That's our deployment application name that we created in code deploy. It's flight search deploy. The deployment group, it's flight search deploy group, and the deployment config name, which is code deploy default dot one at a time. Then GitHub location repository, we can use GitHub's environment variables to select the current repository, and then the commit ID, we're going to do the same thing, so this is the current commit. When you push this code to GitHub, it will trigger the deployment and automatically deploy to AWS. So now I just pushed my code to GitHub, and normally all the deployment process will be triggered automatically. So let's jump into our code deploy service and see if we can see our deployment there. Okay, here under deployments, I can see two because I did it twice to be sure it works. And okay, both of them succeeded. Let's see some details. So clicking on the deployment, you can come here on the deployment lifecycle events, which are the hooks we talked before. And we can see each one of them. If someone fails, you can see why it failed and get some more detail. So everything seems fine here. Let's jump into the CloudWatch service and see if our logs are being pushed. So here we need to go to log groups and select the log group we created. So flight search log group, and finally our log stream. And let's see. Okay, so we see we have some logs here. Server started successfully, environment test, listening on port 3000, and the requests I made to test the app. So cool, the log feature is working. With also in CloudWatch, you can use its features to create some alarms and some metrics, so you have even more synthetic views on your logs. Finally, let's go to our instance, so EC2, and see if we can access the app. To access the app, go to your instance and note its public IP address, which can be found here, and on some browser, tap HTTP and the IP address. Okay, perfect. We have our app here. It's loading. Nice. So let's see if the backend the front end communicates to the backend correctly. Let's launch Gsearch, and we should see some results soon. Okay, nice. We see the results here. It means they are both communicating correctly. Really nice. So yeah, that's it for the deployment. Now we have an automatic CI/CD pipeline fully working, and every time you push code to your repository, it's going to be automatically deployed to your AWS services. Thank you very much for watching. If you have any questions, you can get in touch with us through our different platforms, and also feel free to join our community. We have a lot more interesting content waiting for you.